secant inverse 9s to the 5th plus 5. We get a little blur. Secant inverse 9s to the 5th. I think I said plus 5. Plus 5. First, we need to know what is the derivative of secant inverse x. You guys remember the formulas we did last time?
Oh wait, hold on.
It was already like a weekend ago, so.
Isn't it 1 over the absolute value of x square root of x squared minus 1?
Yeah, very good, Courtney. There's our formula for secant inverse. So the first part of this problem is going to contain that expression, but instead of having just x's here, which is the input here, you will have this input, right, inside there. So you'll have 1 over the absolute value of 9s to the 5th plus 5, root of 9s to the 5th plus 5 squared, minus 1. Okay, so that's the first part of the formula, right? It's just using this expression we wrote down last time. But I need to complete the chain rule. And I've written x here accidentally. It's not really x. My mistake. It's an s. The independent variable is s. So we need to multiply now by the derivative of the inner function, 9s to the 5th plus 5, to complete the chain rule, right? Regular derivative of secant inverse with inner function left inside times derivative inner function. That's the way chain rule always is, right? Derivative of outer with inner inside times derivative of inner. Blue? You're not wearing Oscar the Grouch? Okay, fine. Okay. What is the derivative of 9s to the 5th plus 5?
45s to the 4th.
Right. So 45s to the 4th is going to go up here, and that should be about it. dy ds equals 45s to the 4th over this expression. There we go. Nothing cancels, so that's it.
Wait, you don't do anything to the... Oh, okay.
To the what?
To the inside, like the denominator of the... Okay.
No, I think we wasted time to FOIL that out in minus 1. Doesn't lead to anything.
Okay, yeah, because I mean the inside stays the same. It's just, you're just plugging it in, right?
Only if it leads to something constructive. Doesn't look like it's going to in this case.
Okay.
Alright. So they multiplied it out, it says here, for the answer. But I don't know if that means they would not take what I have written, but they do have it multiplied out, just in case you're wondering. According to how the quiz does have it multiplied out, which I think it's a ghastly waste of time, because it doesn't produce anything. Alright, related rates. Last section in chapter 3, 10. Number 7. Start with this example. It says it is a shrinking circle. So related rates is simply about derivatives that are related to each other. That's all it is. A circle has an initial radius of 50 feet. A circle, radius 50 inside circle. I'm going to try to abbreviate what they say a little bit. The radius of a circle with radius 50 feet begins to decrease. So the radius of the circle begins to decrease. At a rate of 2 feet per minute. Okay, so first let me ask you a question. If you have a circle and its radius begins to decrease, what other qualities, what other facet of the circle also decreases? Area, and diameter, and circumference, right? Basically, everything about the circle begins to decrease, okay? So the rate at which any of those things decreases is related to the rate at which the radius decreases. And they could ask you about any of them if they wanted to, right? But Sereti has the correct assumption here. They're going to talk about area. Okay? What is the rate of change of the area? Find the rate of change of the area at the instant the radius is 10 feet. The instant the radius is 10 feet. So you got this colossal circle, radius 50 feet. It starts to decrease at a constant 2 feet per second. And right when the radius hits 10, pow! How fast is the area decreasing is what you want to find out. Okay? It says instantaneous. That's right. You want instant rate of change. Right? You want to know the velocity of the area, basically. Sounds kind of weird to say it that way, but the velocity of the area. But ultimately, that's what you're finding. Okay? So, in notation, if I called R radius and A area, be careful now. What derivative do I want to find in notation? D something, D something.
D of D and T minus D of R.
D A D what?
Is it instant D of T minus D of whatever the function is?
Where'd you get T? Time. We want to know the velocity of the area. So dA dt. Maybe I shouldn't say velocity of the area too many times. But yeah, dA dt is what you want to find. Okay, that's the rate of change of the area. You know the rate of change of the radius. It's 2 feet per minute. You want to find the rate of change of the area. It's not dA dr. Okay? But you could claim that dA dt, the thing you wish to find, is certainly dA dr times dr dt. That's true by chain rule, right? And that's why if you're comfortable